Hi, this is Mr. M from Algebra Lessons. In this video, I am trying to explain how to solve absolute value equations and inequalities. So, absolute value basically means the distance of the given number or the equation or the expression from zero. Say, for example, if I'm saying absolute value of 5, the meaning is the distance of 5 from 0. Okay, say for example, absolute value of 5 is how many units away from 0. So 1, 2, 3, 4 and 5 units. So this 5 is 5 units away from 0. That's good. So we actually found that this is absolute value of 5. And another question, so this is 5. Another question, absolute value of negative 5. What is absolute value of negative 5? Again, as per our information, as per our knowledge, absolute value always representing the distance from 0. Okay, so count the distance from 0 to this negative 5. We can try with a different color. Okay, so this is 1, 2, 3, 4. That is also 5 units. That's fine. So consider that 5 units. So what I said is absolute value is distance. Distance never been 0. So this is also 5. So we can conclude like this. Absolute value of a number or expression will be the distance. Okay, distance will not be a negative number. Distance can be 0, but it will not be a negative number. So the distance from 0 to a particular number or expression is called the absolute value. Okay, so here we are trying to study how to solve an equation, an absolute value equation, and how to solve an absolute value inequalities. Okay, so before we are digging into the deeper side of this particular topic, we need to understand some basic rules for this particular topic. So if in the process, if you found that the absolute value is found to be 0, you can say that absolute value equation will have one solution. Okay, so if the absolute value is found to be 0, that equation will have one solution. If the absolute value is found to be a negative number, that means if the absolute value of x plus 5 is equal to negative 5, straight away you can write there is no solution. That means the solution set will be a null set. Okay, so you should have this basic information. And when we are dealing with the absolute value equations and inequalities, you may see the following 3 cases of problems. So how can we model this? So if you are watching this video, please copy or please save this information for your future classes or future lessons, because these 3 statements are very important for getting a right answer for your problems. So what are those 3 cases? The very first one is absolute value of x is equal to p. Okay, absolute value of x is equal to p means you can rewrite that absolute value, or you can eliminate that absolute value like x is equal to negative p or x is equal to positive p. That's what we explained in the beginning of this video. Absolute value will be towards the positive side or towards the negative side. Okay, that's what we seen here. Absolute value of 5 and absolute value of negative 5 both are positive. Okay, and if you have an equation absolute value of x is equal to p, say for example absolute value of x is equal to absolute value of x is equal to 5. Absolute value of x is equal to 5. So you can rewrite that as absolute value, you can rewrite that as x is equal to positive 5 or x is equal to negative 5. Does that make sense? I believe because absolute value of x is equal to 5 means the distance of some particular number is 5 units away from 0. So you have to understand in that way, then everything will be easy. Okay, so if you have these kind of absolute value statements, you can rewrite that equations like this. The second one is the less than or equal to case. Here it comes the inequality. If absolute value of x is less than or equal to p, similarly another I will write with a question. I'll explain with a question. So absolute value of x is less than or equal to 3. Absolute value of x is less than or equal to 3. So you can rewrite or you can eliminate this absolute value sign by rewriting this statement as we are using this 3, negative 3 less than or equal to x less than or equal to positive 3. So if you have a less than or equal to inequality with the absolute value sign, you can rewrite with the lower bound and upper bound, and in the middle you can write the argument. Okay, argument means the thing what you have in between the absolute value sign. So we can call it as an argument. Okay, so the you can rewrite the absolute value statement just like the lower bound and the upper bound, and in between you can write the argument. So that is the second case, and that is the less than or equal to case. And if it is greater than or equal to case, so that will be like this. Absolute value of x is greater than or equal to p. That is exactly same as the equation. Okay, in equation absolute value of x is equal to p, then how we rewrite or we eliminate the absolute value sign, x is equal to negative p or x is equal to positive p. Exactly same. Absolute value of x is greater than or equal to p means x is less than or equal to negative p, or x is greater than or equal to positive p. So we can use this information and we can follow this information to solve the inequalities and the absolute value equations. So let me try to explain these rules with some basic problems. I hope you can follow these rules. So one problem, I'm writing one problem number 1. This is absolute value of x absolute value of x x plus 3, absolute value of x plus 3 equal to 5. How can you solve it? Absolute value of x plus 5 is equal to 3. So you have to go back to the equation. Absolute value of x is equal to p means how you will rewrite it without the absolute value sign. That's a question. Okay, without the absolute value sign, you have to write just like the argument is equal to negative of the right hand side, or the argument is equal to the positive of the right hand side. So this will be x plus 3 equal to negative 5, or x plus 3 is equal to positive 5. Solve it. So how can you solve it? Eliminate 3 on both sides by subtracting 3, cancelled out. So x will be equal to negative 5 plus negative 3 is negative 8. That is the first solution. Second solution. So eliminate this 3 by subtracting 3 on both sides, cancelled out. X is equal to 5 minus 3 is plus 2. That is the second solution. Okay, so that is the equal that is kind of the equation. And second one I'm going to write another problem, that is just absolute value of x plus 2 is greater than 3. Okay, absolute value of x plus 2 is greater than 3. So you should have the basic idea what is an absolute value means. Absolute value always representing the distance from 0. So this statement is meaning that the distance from 0 for this argument is greater than 3 units. Okay, so sometimes it will be in the positive direction, or it will be in the negative direction. So how can we rewrite, or how can we eliminate this absolute value sign for this particular problem? Okay, so we can rewrite this as x plus 2 is less than negative 3. See the lower bound thing. Okay, and x plus 2 is greater than positive 3. Okay, so you have to consider the positive or negative cases of the right hand side. Okay, and then solve it. So eliminate 2 on both sides. So this will be x less than negative 5. Eliminate 2 on both sides, and this will be x greater than plus 1. So we have two solutions for this particular problem. So that is the greater than case. Exactly same way you can do the less than case also. And let me try with another problem. If you have two inequalities equal, say for example absolute value of 2x plus 5 is equal to absolute value of x minus 4. That is another question. If two inequalities are same in a question, how can we manage, how can we approach that problem? Okay, so if two absolute value. If two absolute value statements of or two arguments in an absolute value is equal, means you can approach the problem from one direction. That means consider the positive and negative cases of the right hand side of the argument. So this will be 2x plus 5 2x plus 5 is equal to positive x minus 4, or 2x plus 5 is equal to negative x minus 4. So then solve these two statements. That will give you the exact answer. Okay, I'm actually not spending much time on that. We need the inequality case. Okay, so I'm actually trying to use a different color. So okay, so we can consider this problem. 6 times x plus 3 is less than or equal to, okay, we can add little more. Okay, 6 times x plus 3 minus 7 is less than or equal to 5. Okay, so before we approach this problem, for its solution we need to check what is the less than or equal to case. So that is case number 2. So we need to approach this from both ends. Keep the argument on the middle side and use the inequalities on both ends with its lower bound and upper bound. That is case 2. Is saying. Okay, we can approach the problem with that information. Okay, go ahead. So first, before you start approaching this problem with the case 2 theory, you have to isolate the inequality. So for that, you have to eliminate all the numbers or whatever thing with the absolute value sign, eliminate it. Okay, so I'm using a different color. I like to use different colors to do problems. Okay, so first we can add 7 on both sides, cancel out. So 6 times absolute value of x plus 3 is less than or equal to 7 plus 5 is 12. Okay, eliminate 6 on both sides, cancel out. Absolute value of x plus 3 is less than or equal to 12 by 6 is 2. And case 2 theory is saying that absolute value of x is less than or equal to p means you can rewrite this as negative p less than or equal to x less than or equal to positive p. The same thing we can use here, x plus 3, okay, x plus 3 in the middle, and negative of this one, negative 2 less than or equal to x plus 3 less than or equal to positive 2. Then this is kind of a compound inequality. You can solve it separately, then that will lead to the answer. Okay, so this is the way you need to approach these kind of problems. Okay, exactly the same way if I'm using the same problem for the next thing, the greater than. What is the case for the greater than? The greater than thing is if absolute value of case 3, if absolute value of x is greater than or equal to p means this is exactly same as the equation. Use the right hand side with its lower bound and upper bound as a separate inequality, that is x is less than or equal to negative p or x is greater than or equal to positive p. Okay, so we can use the same thing for the greater than case. So question number 5, 6 times absolute value of x plus 3 minus 7 greater than or equal to positive 5. We can check. So exactly the same process, but with a different approach when you are solving the absolute value sign. But before we start solving the absolute value sign, we have to isolate the absolute value. So that is our process first. So add 7 on both sides, cancelled out. 6 times x plus 3 is greater than or equal to 12, and delete or eliminate this 6, that is x plus 3 is greater than or equal to 2. So our case 3 saying that absolute value of x greater than or equal to p means this is x greater than or equal to negative p. Okay, and x not greater than, x is less than. Okay, that's my mistake. Okay, so x less than or equal to negative p and x greater than or equal to positive p. This is the condition for the equation also. So same thing here. So x plus 3 is greater than or equal to 2 means x plus 3 less than or equal to negative 2 and x plus 3 greater than or equal to positive 2. Eliminate 3 on both sides by subtracting 3. Okay, negative 3. So eliminated. So x less than or equal to negative 5. That is the first solution. And next one here also, eliminate 3. So cancelled. So x greater than or equal to x greater than or equal to negative 1. See, two different solutions we have. And see, these are the 3 different cases for the inequality and the absolute value equations. I hope every one of you really understand the explanation. If you like this video and if you really wish to get more future videos related to your content, please watch, like and share this video, and please don't forget to subscribe this channel and don't forget to click the bell icon. Thank you.